Okay, so we need to talk, actually we're on the wrong slide here. We need to talk about other organic molecules, and we're not going to name them all, but we are going to talk a little bit about them, and also about the reactions that can happen, and really just one specific one. So these are called functional groups, other organic molecules, and when I draw these, what I'm drawing when I draw R is I'm drawing any type of carbon chain. It could be an alkane, it could be an alkene, it could be an alkyne, it could have all kinds of branches off of it, it could have another one of these functional groups as part of it, it could be anything. So when I draw the R, what I'm drawing here is, it just could be anything. Any number of carbons, it could be one carbon, it could be 50 carbons. Okay. Now, what makes an alcohol is this OH. So when you see a carbon chain of some sort with an OH off of it, that is an alcohol, and naming it, you end it with OL. But again, we're not going to talk too much about naming those kind of things. But this is an alcohol. There are a couple others here too. We have a ketone. Now, a ketone will have some sort of chain, and it will have a carbon that is double bonded to an oxygen, and then it's got another R group that it's connected to. So this could be any type of, again, any carbon chain this way or this way, and the most common one here would be acetone, and acetone is like nail polish remover. I'll show you a demo when I get back. This is acetone. It's just the most simplest ketone with the hydrogens there. One of the things that you might have heard, like a keto diet or something like that, or ketoacidosis, when you are in the starvation mode, you can, or you're in danger of getting ketoacidosis, and that's where ketones build up in your blood, and your blood pH drops. And now your blood is a pretty good buffer, meaning it's very resistant to changes in acid or base. But if you get too many of the ketones dumped into your bloodstream, it just isn't as good a buffer, and the pH drops, and you can get ketoacidosis, which can be fatal. So generally, if you just cut down on carbs, you're in no danger of that. But if you're continually starving your body, or if you're in the starvation mode, that is one thing that will kill you. The next one here, carboxylic acid, is some sort of R group, double bonded O, and then you'll see a little OH. So you might say, well, that's an alcohol, but combined with this carbon double bonded, this whole thing right here, this functional group, is called a carboxylic acid, and those are very common. Vinegar, acetic acid, is a carboxylic acid. Stearic acid, the fragrance in a lot of soaps and oils, and then formic acid is what, if something bites you or stings you, that formic acid is usually what is deposited, and it hurts. Let's see. Esters. Esters are going to be very similar. You're going to see an ester. Oops, there's little dots right there. And an ester is very similar, but what you get is this. So this is going to be connected not to a hydrogen, but to another R group of some sort. Now we're going to take these carboxylic acids and actually make the esters out of that. That's what's coming up here. Esters are really interesting, and we're going to be doing a lab on those. I don't think we'll have time to actually make an ester, but we're going to smell a bunch of them. Flavors and smells are generally esters. Any kind of fruit, raspberries, banana, pineapple, grapes, oranges, apples, are going to have a naturally occurring ester in them that you can reproduce and put in things. Wintergreen, cinnamon, rum, lavender, sage, root beer, all of these things are esters. So those are pretty interesting things. An aldehyde is an R group. The C got a double bond O. You can see that that's pretty common. And then it just ends with an H. That's an aldehyde. So that is going to be at the end of a carbon chain, because you can't, you can't keep going here. Hydrogen is it. Hydrogen can't do more than two. Aldehydes are in certain fragrances too, like Chanel No. 5. You can have vanilla and cinnamon are also aldehydes that smell really good. And also formaldehyde does not smell that good, but that's used to preserve animals, but that's a known carcinogen too. All right, ether. Ethers are this R, O, and then another R group. Okay, and the thing about ethers, they used to use it way back when as a try to put people under, and it will knock people unconscious. Usually, it just makes them feel really high. But the other problem with ethers is that they can form explosive peroxides. So if you have like benzoyl peroxide, which is just sort of like an acne medication, but if you get in too high concentration, it can form explosive peroxides. Or hydrogen peroxide, which you normally think of just like in the cabinet to disinfectant. But that can also cause huge problems. That one, and here's phenol. Phenol, I'm going to draw it out. Now, I'm going to show you a better way to draw this thing because, as you can see, there's a lot, and every carbon has to have 4. So you draw these hydrogens in that are attached. And those double bonds have resonance. They're all sharing those double bonds, so it's in between here, and they're all sharing those double bonds there. And so because they're sharing those double bonds, what we get is something called a phenol group or a phenyl group. And all we do is draw it like that. We draw a circle in the middle, and that is the phenyl group if you were to attach it to an R. Phenol, I'll be specific and say phenol is going to have an OH on here. So phenol would have an OH, a phenyl group. I should have just said phenyl. Phenyl group would be this with this thing right here. Take one of the H's off and connect it to an R group like that. Phenol would be this thing, but instead of the R, it would have an OH on it. It's a type of alcohol. Interestingly, oops, if I can do this. There's something called picric acid, which has been somewhat of a problem in laboratories because it is very similar to TNT. TNT, the explosive, has a CH3 on top, and what it has at every corner here is an NO2. So that's trinitroglycerin, TNT. And if you just take this off and replace it with an OH, you have something called picric acid, which actually can form from those explosive peroxides up here. Certain peroxides can form explosive phenols. And this is picric acid, which has, got to be really, really careful with that. I should tell you a story of my encounter with picric acid. All right, so those are some functional groups that you need to be familiar with, and definitely write those down. Now, organic reactions. So I'm going to look at a couple of organic reactions with you. And the first one, or the only one that I want to look at, is ester formation. So all of those really nice smells from esters that do like any of the fruits I mentioned, or wintergreen, or cinnamon, or anything like that, are esters. And where they come from is an organic ester, which you have here. That's your organic acid. And you have an organic alcohol, and if you remember, the organic alcohol was an OH with R. Now I should put these on, these lone pairs, but we get kind of lazy in organic chemistry, and we don't necessarily put those on. So what's going to happen here is we are going to have a reaction, and there has to be a catalyst of concentrated sulfuric acid. And so when we do this lab, if we were to get to that next week, I have to be really careful. That 18 molar sulfuric, it just blackens and destroys your skin upon contact. So, but you do need to have a drop of that in acting as a catalyst, which a catalyst speeds up a reaction without getting involved in it. So that's what it does here. And what ends up happening is this comes off. Now, that's two H's and an O, that's water. So a water molecule comes off, and then what happens is this bond comes on over here and attaches here. Okay, so this is sometimes called a dehydration reaction because we're removing water. But what I'm going to do is I'm going to redraw the organic acid. And instead of putting the OH, what I'm going to do is come over here, attach it to the O and the R. So then what ends up happening is you form this ester. From this organic acid, from this organic alcohol, you form an ester. So I'm going to show you a couple of different kinds of esters. So very specifically, let me show you what happens when I take, now there's a couple of them here. Let's take a phenyl group and let's make it phenol. Here, actually, you know what, I'm going to take this and make it the acid part. Okay, so this is the acid part. I'm not going to put all the lone electrons on oxygen. And I'm going to put it with a very simple methanol. So, methanol here. Okay, again, I'm not doing the lone pairs. Water is going to come off. It forms water. And then what I form is I'm going to redraw this. When you do these, just redraw them. Okay, it had a little OH off of this. And then it had C double bond O. Now, instead of drawing this OH, I'm going to connect it over here. This is going to come over here. And I'm going to go O, C, like so. Okay. And again, I can then put these in here like so. Should be there. All right, so this particular one is makes wintergreen. So your wintergreen lifesavers and such would have this smell and this flavoring in them. Show you one more here because we're kind of ending the video. So I'm going to show you this last one here to make banana smells, which they use a lot to test out oops, I think that's it. Respirators. So when they test out respirators, what happens is they put this banana oil, they break the little ampule, and banana oil smell comes out. And if you can smell it, you know that your respirator is not fitting as well as it should. Okay. Now in the Army, I think they just do smoke and you start choking if your respirator isn't working. They're not as kind and nice in the Army. All right, so what's going to happen here is this is going to come off and form water. This over here is going to connect here, and we are going to make banana oil. So I'm going to redraw this, and I'm going to connect it instead of this. I'm going to connect it over here to O, and then we're going to go 1, 2, 3. That had 4, and this one has another CH3. Okay, so this is the banana oil. That one's good. These done below pairs. This needs a couple of hydrogens. It needs a couple of hydrogens. That just needs the 1. This needs 3, and this needs 3. And that is the ester that is for banana oil. And we won't get into the naming of those, but those are the esters. All right, video 1 is done.